Welcome to the deep dive. Okay, today we're tackling something that sounds, well, almost impossible. Solar power doing really well in Duluth, Minnesota. I mean, you think Duluth, you think cold, snow, lots of rain. So how on earth are they making solar work so effectively there? Let's unpack this.
It's a great question. And we're digging into this white paper, Black Knight Power, which lays out exactly how Duluth isn't just coping, it's actually optimizing solar. Our mission today is really to pull out the key insights on how precipitation, some clever tech, and local initiatives make this possible.
Yeah, because the climate stats are, well, challenging. Average 31 inches of precipitation, lots of snow. But interestingly, also about 180 sunny days a year. And this is where the engineering gets really smart, isn't it? The panel tilt angles.
Exactly. It's crucial. Many places stick with, say, 20 or 30 degrees all year. But in Duluth, they're using dynamic tilts, sometimes pushing up to 60 degrees in winter.
60 degrees, that seems steep.
It is. But it's not just about catching that low winter sun. It's brilliant because it helps the panels shed heavy snow automatically. So a big obstacle kind of becomes part of the solution, a self-cleaning mechanism almost.
Huh, that's clever. And it's funny how precipitation itself is a bit of a double-edged sword then.
Right. A bit of rain can actually be helpful, washes off the
A
dust.
free cleaning service.
Sort of, yeah. But obviously persistent rain or heavy snow cover, those are the real hurdles, and that's where the specific technologies come into play.
Okay, so what are we talking about?
Well, adaptive tech is key. Think automated cleaning systems like the solar panel cleaning robot, the SPCR. It uses these little crawler things to clear off snow and debris. You see them a lot in, say, big parking lot setups.
Ah, okay. Makes sense for large areas.
And then there are bifacial panels. These are really cool. They capture light from both sides.
Both sides. How does that work?
So especially in Duluth with all the snow, the white ground reflects sunlight up onto the back of the panels. It can boost energy production by maybe up to 12%. The snow actually helps.
Wow, turning the snow into an asset.
Exactly. And there's also growing interest in Minnesota in vertical installations. Think panels mounted sideways on buildings.
Vertical. Why?
Well, it could help with heat dissipation in the cold, potentially less snow accumulation too. The Nordic Ware factory array is kind of an early example exploring that idea.
Okay, so the tech sounds impressive, but where can we actually see this stuff working, making a real difference in Duluth now?
Right, let's look at some real-world examples. The Gene Duluth Solar Project is a big one. It's 1.6 megawatts, nearly 3,800 panels. They use single-axis tracking, so the panels follow the sun, and they've treated the ground surface to increase reflectivity, the albedo.
And that helps with the bifacial panels.
Precisely. They're seeing about a 10% boost in winter production just from that snow reflection.
Hey,
And that project powers about 300 homes.
300 homes, that's significant.
Definitely. And on a smaller scale, you have Frost River Trading. They put in a 140-panel array. Get this. They reported a 4-year payback period. 4 years. And their summer electricity costs are basically zero now. It just shows it can make solid economic sense.
A 4-year payback is incredible, so it's clearly working for electricity generation. But you mentioned optimizing. Is solar being used for other things beyond just power?
Yes, and this is where it gets really integrated. Think about agriculture, solar-powered irrigation systems. They use sensors in the soil, check weather forecasts, and only water when needed. Cuts water waste by maybe 40%.
40% water saving, that's huge.
It is, and the University of Minnesota is doing research on agrivoltaics, basically growing crops under solar panels. They found certain shade-tolerant crops actually had a 15% higher yield under the panels.
Farming under the panels. Okay, that's synergy. What else?
Stormwater management. Solar canopies, like the big one over the parking garage at Target Field, aren't just holding panels. They're designed to channel rainwater effectively. It reduces runoff, which is a big deal in cities, and helps minimize ice buildup by diverting something like 60% of the rain away from the pavement.
So the structures serve multiple purposes, but things like large canopies sound expensive up front. How are these projects financially viable? What's the policy situation?
You're right. The initial cost can be higher, but the financial support structure is pretty strong. You've got state grants, federal tax incentives. Together, they can offset maybe 40 to 50% of the costs.
Okay, that helps significantly.
Absolutely. And Minnesota Power offers rebates, too, $2.59 per watt for systems feeding the grid. Plus, and this is critical, Duluth has its 2035 carbon neutrality plan. It mandates that 30% of the city's energy must come from solar by 2030. That kind of policy really drives investment and makes things happen.
Right, that policy certainty is key. Okay, so let's try and wrap this up for everyone listening. What we've seen today is that Duluth's solar success, even with its tough climate, really comes down to a few core things. First, using those adaptive technologies, the cleaning bots, the bifacial panels, the smart tilting, you absolutely need them. Second, thinking bigger, integrating solar into hybrid systems for water management, agriculture, you name it.
Yeah.
And third, you need that strong policy push and the financial incentives to make it all pencil out.
Exactly. And if you zoom out, Duluth really demonstrates that even in places you wouldn't expect, solar can be a really robust, integrated solution. Not just for energy, but for resource management, too. It makes you wonder, doesn't it? What other supposedly unlikely places could become leaders in renewables if they just find the right mix of technology and policy support? Something to think about.